This is chapter 5.4 and it's about making a decision. And it says the machine used to fill gallon-sized paint cans is regulated so that the amount of paint dispersed has a mean of 128 ounces and a standard deviation of 0.20 ounce. You randomly select 40 cans and carefully measure the contents. The sample mean of the cans is 127.9 ounces. Does the machine need to be reset? So here's the mean that they say is supposed to be dispersed, and this is what you're finding once you sampled 40 cans. So you can determine the likelihood of X bar is equal to 127.9 by calculating how far away 127.9 is from the mean 128. So what you do is you can calculate this. You can do this by calculating how much area there is under a normal curve, because this is a normal curve, and what's to the left of 127.9. So the smaller that area is, the further 129.9 is from the mean, and the more unlikely 127.9 is going to be correct. So then the machine will need to be reset. So here's what we're going to look at. You're going to go on your calculator, the same thing we've been doing with the lower bound, the upper bound, the mean, and we need an X bar because this is the mean actually after you've sampled 40 cans. So we're going to do the same type thing. So let's take a look at that on the calculator. And here's what you're going to see. Second distribution down to number 2, negative 10,000. 127.9 is going to be my upper bound. 128 is my mean. And then I need the standard error, which is the X bar. So I'm going to put the standard deviation divided by the sample size that we looked at. And it's so small that it puts it in scientific notation. And because this is in scientific notation, this negative 4 means that I've got to take this decimal and move it 4 places this way. So if I start with the decimal here and I move 4 places that way, it goes around the 7 and then 3 more zeros. So that's a very, very small number. You'd have to round it to 4 decimal places. 2 decimal places wouldn't make any sense. And so the machine needs to be reset because the area is so small. Because remember I said the smaller the area is, the further that this is from the mean. So it's unlikely then. You wanted to see if it was likely that was close enough to the mean. It looked like it was close to the mean when we, if you just look at the numbers, but actually it's not. It's more than 2 standard deviations from the mean of the sample means. And see, this was your standard deviation, so your standard deviation was not very much anyway, but that's more than 2 standard deviations. And remember, we never want anything to be more than 2 standard deviations. That tells us that there's something wrong. So they do need to reset that machine. It's not putting the right amount of paint in the bucket.